How does the West Antarctic Ice Sheet compare to the East Antarctic Ice Sheet? Have you ever wondered how the massive ice sheets of Antarctica differ from one another? Today, we will look at the West Antarctic Ice Sheet and the East Antarctic Ice Sheet, comparing their size, stability, and vulnerability to climate change. First off, let's talk about size and location. The East Antarctic Ice Sheet is significantly larger than the West Antarctic Ice Sheet. In fact, it is over 10 times bigger. The East Antarctic Ice Sheet covers a vast area of East Antarctica and can reach thicknesses of nearly 3 miles, which is about 5 kilometers. On the other hand, the West Antarctic Ice Sheet is smaller and located in West Antarctica. These two ice sheets are separated by the Transantarctic Mountains, which rise about 2,000 meters high. Next, we need to consider their grounding. The East Antarctic Ice Sheet is largely grounded above sea level. This means its base rests on bedrock that is mostly above the ocean. In contrast, the West Antarctic Ice Sheet is mostly grounded below sea level. This makes it a marine ice sheet, with much of its ice resting on bedrock that lies beneath the ocean's surface. This difference in grounding makes the West Antarctic Ice Sheet more susceptible to ocean water intrusion beneath the ice. When it comes to stability and vulnerability, the East Antarctic Ice Sheet is generally considered more stable. Its higher elevation and grounding above sea level help limit ocean water penetration, which slows ice loss. In contrast, the West Antarctic Ice Sheet is more vulnerable to climate change. Since its ice rests on bedrock below sea level, warm ocean water can access the ice sheet base, accelerating melting and glacier flow. Fast-moving glaciers in West Antarctica, like the Pine Island and Thwaites glaciers, are currently in irreversible decline. The impact of climate on these ice sheets is also noteworthy. Over the 20th century, the West Antarctic Ice Sheet has warmed noticeably, with ice loss from glaciers exceeding any gains. Meanwhile, the East Antarctic Ice Sheet has experienced limited cooling or slight net mass gain due to increased snowfall. The West Antarctic Ice Sheet contributes a substantial portion of Antarctic ice loss, generating large volumes of fresh meltwater that affect ocean circulation. If the West Antarctic Ice Sheet were to collapse, it could raise global sea levels by several meters. In contrast, the entire Antarctic Ice Sheet holds enough ice to raise sea levels by about 60 meters. Finally, let's consider what these regions would look like without ice. If the ice were removed, West Antarctica would largely become a series of islands due to its low-lying, below-sea level bedrock. In contrast, East Antarctica would remain as a more continuous landmass because much of its bedrock is above sea level. In summary, the East Antarctic Ice Sheet is larger, thicker, and more stable, while the West Antarctic Ice Sheet is smaller, grounded below sea level, and more vulnerable to melting and collapse. Understanding these differences is essential for grasping the dynamics of Antarctica's ice and its future impact on global climate and ocean systems.